Okay, YouTube, what I want to explore in this video is how to graph functions. Essentially, this is something that we've already accomplished before when we've studied relations of x and y. But essentially, what we're going to see here is this. When we graph functions, say, such as f of x equals 2x and g of x equals 2x minus 3, we'll go ahead and just make a table of values. And you'll notice here that I say start with -2 and end with +2. So I've made a doubly augmented table here because what I'm going to do is I'm going to put my function values for f of x in one side, or one part of it, and then I'm going to put my function values for g of x in the other. So basically all we need to do is come up with some solution pairs or ordered pairs that are in each relation, and then plot the points there and connect the dots. So we get -2. Now if I plug in a -2, I say what is f of -2? What I'm going to get is 2 times -2, which comes out to be a -4. We can see though that basically with our first rule here, it's 2 times whatever we put into it. So we're always going to get double the value of what we put into it. In this case we get -2. So if our rule is double the 0, we get 0. Double the 1, we get 2. And double the 2, we're going to get 4. Now, g of x, what I want to go ahead and start by noticing is this. It seems to be related to f of x. As a matter of fact, it has the 2x part, but then we're going to subtract 3 off of all of those. So I'll plug in just a couple of these. G of -2 would be 2 times our input minus 3. In other words, we're going to get -4 again, but then we're going to subtract 3 off of it, which is -7. So I'll put -7 right here. And then also we'll check one more. We say g of -1. So again, we're going to double the input this time, double it, but then we're going to take 3 off of that, which gives us this time -2, take 3 off of that is -5, -5 here. What I keep seeing is I'm just 3 less than our f of x relationship here. So it's 3 less than 0 would be -3. 3 less than 2 would be -1, and 3 less than 4 would be 1. So what we're going to do is we're going to go ahead and plot these points here, and what I'll do is I'll plot these ones in green. So I'll put a little green box around it here. But we say -2 comma -4, just like when we plotted solution pairs in the past. We'll just throw these on the graph. So we'd say -1 comma -2. It's also in our table of solution values. 0, 0 goes through the origin. We say 1 comma 2 and then 2 comma 4. So this is important, but we do need to connect the dots on this. I'm going to try to do this as cleanly as possible here. And you want to label it. Whenever you graph a function, let's give it its name, f of x. So g of x, we had -2 down 7. So -2 down 4 was this point. Remember, we were just down 3 more from here. So if I'm saying, well, how is the graph of g related to the graph of f? We just keep noticing here that it's 3 less in value than all the y values or function values from the original relation. So -1 comma -2 is on our original graph. Well, -1 comma -2 minus 3 more, which is -5, is on this graph. This will be down 3 points from our origin point here. This will be down 3 points from here. And this will be down 3 units downward. So I'm going to go ahead and connect the dots on this as well. So we'll connect the dots. And, I say, how are these related? Well, first of all, I notice that the graph of g of x is translated down 3 units. So I do want to make sure we put a note in here about this. But we say g of x is a vertical translation downward 3 units from f of x. But also this, you might notice that g of x and f of x never intersect. In other words, are parallel lines. But that's how you'll graph a function. You just make a table of values and plug and chug. Cheers.